Can you see my screen?
Yes, sir.
Fine, that's great. So now what we are going to do in this class, actually, I will do some frictional problem with the competency part. Actually, it's a little bit challenging problem in your level. It should be. It's a little bit standard problem, I will say, from my side. So that's I try to understand what I'm doing this part, and this is very important. You have to understand this part, and then I will move to that one more new topics that's called actually uniform circular motion or the circular motion part, right? Remember I said when I'm talking about the motion part, I didn't talk about circular motion part because I said that to understand the circular motion we need to introduce the idea of the force. At that time we didn't talk about the force, so that's why I didn't talk about that circular motion. Right now we already talk about the Newton's law of motion with friction and without friction, so that's how we'll again go back to actually circular motion. Yes, Kabu, what is the issue? Why you people guys ask for be honest, is my English is too bad? Come on guys, speak up, don't be silent.
No, sir.
No, sir.
Then why you ask me to take a class in Bengali? Yeah, that's true, but that's the policy of the university. I love to also say in Bengali. I'm bound to I'm bound to teach actually, or I'm bound to talk in English in the class. I said it before. But the problem is if I say the Bengali, then the people actually some of you, I'm not saying that it could be, I do not know what you will do actually. You will say that teacher does not say any English in the class. I have that experience actually, so that's why I'm saying that I'm not feeling well to teach in English actually. I will love to take my class in Bengali, but I cannot do that one because that's the policy of the university. What I can do actually, I can say the Bengali terminology for you. So if you do not understand, you can say the Bengali. That's not a big deal. You can say whatever you like, but I cannot say the Bengali in that class. That's the big issue. So if you do not understand anything, please raise your hand. I will try to say 2 or 3 more times, but I cannot say the Bengali in that class. It's very hard actually. We can discuss in counseling hour if you need that anything extra. We can discuss after the class in the Bengali, but not in the class or the class time. I do not know actually. Yeah, I know it will be very helpful for you. Some of that faculty are doing that one, but if I can do that, if the university say me that, then well, you can say the Bengali or you can teach the Bengali in the class, I'll be very much happy. I'm sorry, Kampo. I have a very bad experience about this English actually. Some recent year I also got the feedback from the student, my English is very poor. I cannot say the English in the class. How funny that thing. So people are saying that my English is not good. So that's why I'm asking you honestly actually, is my English is too bad? So that's why you probably are asking to take that class in the Bengali. Alright, so can you see my screen, right? Kabo?
জি স্যার দেখা যায় সমস্যা নেই
Great. Don't be deserted.
সমস্যা নেই
Alright, let's say this is a block on a surface which has a 300, this is the weight of this block which is a 300 Newton, and I apply a force over here to push the system towards the forward direction by applying a force making an angle 30 degree. So let's say this is the force actually, the P, and P is applying that 200 Newton. Due to that, that system will move towards the forward direction with some acceleration. They give us some information over here actually. It is start from the rest, the block, and they give us when it start to the move, after t equal to 5 seconds later, 5 seconds later, what should be its position and that velocity. So they give us two more information, the coefficient of static friction, which is 0.3, and coefficient of kinetic friction actually that 0.2. Do you understand the question? So we have a block which has a weight actually the 300 Newton, and you are applying a force 200 Newton on the block, making an angle 30 degree. Due to that force, the block moves towards the forward direction with some acceleration that we need to find out actually. So this is the x direction and this is the y direction, and once it start to the move, after t equal to 5 seconds later, I have to find out what should be its velocity and what should be its position. I'll choose my origin over here. Alright, so for that one, I need to draw the free body diagram over here. So if I draw the free body diagram, you'll find out the forces is acting over here. One is actually your mg, which is 300 Newton. This is would be your normal reaction force, right? And this 200, which is your applied force, the P, I'm going to extend that one actually. Let's extend that part. It will be towards that direction. Then I will find out one component will be toward that direction, which is 200 cos 30 degree, and the downward direction should be 200 sine 30 degree. Is that okay? Is there any more force rather than this? What do you think?
Frictional force.
Frictional force, exactly. Very good. So that should be towards.
Sir,
Yes.
200 sin 30 ওটা উপরের দিকে হওয়ার কথা ছিল না?
Yeah, that's the issue. Very good question, Kappo. Very good question. So come over here. So let's say you have one vector toward that direction, another vector towards that direction, which is, let's say, your familiar symbol P and Q. Then what should be the resultant vector? Where should be that vector resultant? It should be over there, right? Right, Kabbo? Which is actually the R.
Yes, sir.
Now I'm saying in the opposite direction. Let's say I have a vector R. Now I want to find out the component of this vector. One vector should be that direction, another vector should be that direction, which is vector triangle law again. So that's mean one vector toward that direction and another vector. This one I am changing its position from here to here. This is my P and this is my Q. And if you say this one vector in that direction, another vector in that direction, 200 sine theta, then resultant vector would be should that one. But it is not, because I extended that one, which is this one, 200 Newton, which makes a 30 degree over here. So that's why this would be the one component 200 cos 30, and second component would be that direction. Then would be resultant vector would be that one. Do you understand right now?
জি স্যার বুঝছি।
Yeah, it's a vector triangle law again, or the component. That's the problem actually. We do not understand or we do not take the vector seriously. If we just can add or subtract or find out that multiplication, then we say that the vector is done, but that's not true. Vector is a lot of things could be done with the vector. Vector is very important thing. Alright, so this last one should be, this is the frictional force, but I do not know what type of friction it would be, whether it is stationary or that kinetic frictional force. So you need to check that one also. So let's say If the block is not moving, then what should be the answer of these two questions, displacement and the velocity?
Zero.
Zero.
By default, it should be 0, right? So that's why when they give to this information, coefficient of kinetic friction and coefficient of static friction, then you need to certain, or you need to check that one whether the block is moving or not. If it is not moving, then these two answer by default it should be the 0. All right. All right. Now, what should be the condition to move that block towards the positive x direction? The condition should be your applied force or force towards the positive x direction must be greater than Fx max, right? Your applied force must be greater than actually Fx max. I said that one actually when I'm talking about that frictional case. Can you remember that part?
Yes, sir.
Alright, so now what should be the Fx max? Fx max should be mu s into n, right? So what is the mu s, or what should be the n? I need to find out that n. To find out the n, what I'm going to do, I'll write the net force along to the y-axis must be the 0.
The 400.
What is the normal reaction force?
N. Reaction force N. 400. 300 plus 100.
Yeah, that's good. So it's going to be that n minus mg minus 200 sine 30. Sine 30 actually the 0.5. So that's why he said that mg actually that 300. So then it's going to be n should be mg plus I write down the directly 100 because sine 50 actually the 0.5. So the mg actually the 300. So I'll find out n should be that 400 Newton, right? So that is actually the reaction force. Fine. If I find out the reaction force, then I will be also find out that Fx max. So Fx max is going to be in that case mu s actually the 0.2 into 400. What should be that in that case? Probably this.
Sir, 0.3.
Huh?
US 0.3.
Yeah, sorry, 0.3. Thank you very much. So
120.
so it should be 120 Newton. Fine. So this is my Fx max. So if the block wants to move to the forward direction, then your 200 cos 30 degree must be greater than 120. Then it will move, right? Do you understand that part? If this block want to move to the forward direction, then it has to this net force towards the positive x direction must be greater than this Fx max. I find out this Fx max, which is 120 Newton. Now I have to find out that applied force towards the x direction, which is Fx. I'm writing simply, which is I can find out 200 cos 30 degree. What should be that value? Kabbu, can you find out?
173.205.
173.20 Newton, which is greater than actually that Fx max. Then I can say that it will move, right?
Yes, sir.
All right. So if it is moves, then I can also find out this acceleration also, right? So if I can, and now one more thing actually I need to understand over here. If it is move, is the block will move at a constant velocity or constant acceleration? Because why am I asking that? If it moves at a constant velocity, then acceleration should be the 0, right? It will move at a constant velocity. If it is not moving at a constant acceleration, then it should be different actually. So that's why I need to also understand that part. Can anyone tell me whether this block is going to move at a constant velocity or constant acceleration, or neither not?
Constant acceleration.
Why it will move at a constant acceleration?
মনে হয়েছে sure.
No,
জানি না।
that's
Sir,
very
we are applying a force. That's why it should be moving at a constant acceleration.
exactly. Yeah, your answer is right, Kapo. It will move at a constant acceleration because you're not changing the force. You're applying the constant force, 200 Newton. Are you going to change that force? That information not given,
That's
right?
force.
If the force is constant, you are applying that 200 Newton. The angle is not changing. nothing is going to change, because after it start to the move, your kinetic frictional force, which is the Fk, that is also constant, right? Fk is constant. Fk is not going to change. Remember, I draw that curve actually when I'm talking about, so the frictional force, your applied force versus frictional force. Frictional force when you start from the rest, sorry, it is start from the rest, it moves, reach a maximum point, then suddenly it drop, right? Once it's drop, then it moves at some constant value. Remember that curve I discussed? This is actually your fx max, and this is actually your fk. So that's mean this fk is not going to change at all. Your 200 cos 30 over here, this is, and your fk when it is moving, this is fixed. It's not moving, it's not changing at all. It means that the force on the block is fixed. It's not going to change at all. That's why if the force is not going to change, m is not going to change, then definitely it will move at a constant acceleration, because we are going to apply the f equal to ma. So that's why it will move at a constant acceleration over here. Sometime I will ask you, this is the comprehensive problem. Look at this, I'm doing that frictional force, but I'm also asking you the question related to the motion. Fine, so that's it will move at a constant acceleration. That acceleration I'm going to find out over here. If I want to find out, then what I'll write down net force along to the x direction. Right now it should be ma. What are the force along the x direction? Right now it should be 200 cos 30 degree minus fk, because it's moving. I'm not writing fs over here. That must be equal to ma. Then I'll write a should be 200 cos 30 minus fk divided by m. I have to find out because they give me the weight. I can write down this one more line. So it should be 200 cos 30 minus fk should be mu k into n. I find out also the n divided by m should be over here. So if I just plug in that value, I'll find out it will give me a should be 200 cos 30 minus mu k, actually the 0.2, n is 400 divided by m should be 300 divided by 9.8. Am I right? Alright, so if you solve that one, you will find out that the acceleration of this block is going to be plus 3.04 meter per second square. That should be the magnitude of this acceleration. Because they are not asking about this acceleration, so that's why I'm not giving the direction over here. I have to give the direction of the displacement and that velocity, because those are two factors they're asking over here. Alright, so if I know it moves at a constant acceleration, then I can use those formula actually. But instead of doing that one, I'll show actually how to, let's say if the system is not moving at a constant acceleration, then how you're going to find out that velocity and the position function. That would be exactly the same procedure. This is the general procedure I'm doing over here. Fine. So what I'm going to do, I'll do the, Kapo, do you know how to do the integration?
Parina integration.
I said you to go through the YouTube to understand how to do the integration. Did you do that one?
ফর্মুলা জানি, জাস্ট বেসিক যেগুলো পারা যাবে।
Oh, that's
কিন্তু
good.
যেগুলো
That's good. So at least you can solve this part over here. All right. So we define that acceleration a actually dv over dt, right? Kapo?
Yes, sir.
So I give that definition when I'm talking about, when I'm discussing about the Newton's law of the motion. I also show you how to find out those parts. I show you the derivation of this quantity. All right. So if I want to find out that velocity, what I'm going to do, I'll take that cross multiplication of this one. Can I do that one? I just take the cross product of these two quantity over here. Then I'll find out, to find out that one, I'm just going to integrate this part over here. So if I integrate, I'll find out this thing is the v, right? If you take the integration of the dx, what you get? You get the x, right, Kabo? Do you know that one?
Yes, sir.
So that's why if I integrate dv, I'll find out the v over here. But this one, I need to give some time over here. So what I'm going to find, So let's say it is start from the time t1 to t2. T1 actually should be the 0. I start to the count to the time actually. Then what I am going to find out over here, so let's say is start from 0 to t second. So what the value of a I find out, which is actually 3.04. This is the value of the a into the dt, plus there should be a c over here. I'm supposed to write that constant over here, some c1. All right. So then what I'm going to get, this v, what it will give me if I integrate this part? Kabo? This thing is constant, right? This should be t plus c1. This should be the velocity. This is the velocity equation over here. Now I have to also find out this. Let's find out that let's keep it. This is the equation number 1. Then I will find out the value of c1 and the c2 at the end part. Then it will be, according to this equation, I will find out that velocity, and to find out the position function, I can define this velocity also. That's going to be that dx over dt, right? Plus this thing again I can find out dx should be v into dt. I take the cross product, then I am going to also integrate this part. If I integrate, I'll find out this should be the dx will be give me the x. This one I need to plug in the value of the v over here. If I plug in the value of v, that should be 3.04 t plus c1 into dt, right? Can you write this one? And again I will write down this one. It should be 0 to t actually, the integration limit, because when I start count down the time, which is actually starting from the 0, t equal to 0 second. Fine. So now if you do the integration, what it will give you, so you can separate this one, or I can just write down the directly. What I will get over here, it will give me actually 1.52 t square, because this thing actually the first part 3.04 t into dt, you know that x into dx actually it should be x to the power n plus 1 divided by n plus 1, right? So power is 1, so that's why it should be x square t square divided by 2. That 2 will be divided this constant over here, plus it should be c1 into dt, it should be c1 into t, plus there is one more constant actually, the c2. For this integration you will find. So this should be basically your displacement equation. Obviously it should be, it look like exactly the formula. I give you the standard formula for when the system moves at a constant acceleration. Look at this c1 and c2 you can find out, you can consider, which is x naught and v naught t into half of a t square. In that case acceleration would be that part, it is moved in that way, half of 3.04 t square, which is exactly that equation for a constant acceleration. Alright, so I am going to find out this constant value. I know at t equal to 0 second, what was the velocity of the block? When just I start to count down the time, at that moment the block start from the rest, right? Once it start to the move, then the v is 0, and my x would be also the 0, because I choose the origin where I apply the force. So that's why in that case x naught would be 0, because I am choosing the origin over here from here. Then my x naught initial displacement actually is 0, right? So that's why I am saying that at that t equal to 0 second, v naught would be 0 and x naught would be the 0. Then what your implies, the equation 1 will be implies. Look at this, your equation 1. If v is 0, t is 0, then the c1 would be 0. You can find out c1 equal to the 0, and if you plug into this equation, then c2 would be also the 0, right? Then I can write down this c2 is also going to be the 0. Now if you plug in, then your yes.
স্যার ইলেকট্রিসিটি চলে গেছে স্যার, আমি ফোন দিয়ে ঢোকার চেষ্টা করতেছি এন থেকে বেরিয়ে।
Or then what I have to do?
স্যার জুমে অ্যাড করেন আমার, আমি এতক্ষণ ক্লাসে ছিলাম।
So join the class. All right, so then I'll find out the v would be simply 3.04 into t. This is my velocity equation general, and my x should be 1.52 t square, right? If I plug in c1 and the c2 into equation 2, then I'll find out these two equations. That would be my displacement equation, and this would be my velocity equation. All right, so then find out, they're asking me to find out this velocity and this displacement at t equal to 5 seconds later. Then I'll find out this v5, that's mean the velocity I'll write down in terms of vector. So this v5 should be 3.04 into 5 is going to be that 15.2 I hat meter per second, and that x5, so that's mean that position or the displacement of the block at t equal to 5 seconds is going to be that 1.52 into 25, that's going to be that 38 I hat meter. So that's the answer of this question. All right, do you understand this part?
Yes, sir.
Fine. Let's move the forward. I don't know I can finish this part today or not. Oh God. Let's say this is a case, there are two blocks one upon another. This is that block M1, this is that block M2. What happened, this block M1 actually that connected this wall by a string, and I drag this block M2 with a force 20 Newton. Due to that force, this block will move, right? There are some information over here. The mass of this block M1 actually 1 kg, mass of this block M2 actually 2 kg, and these two blocks are the same material, so that's why that coefficient of kinetic friction, both the lower and the upper surface of the block, which is mu k actually 0.4, it's moving actually, so that's why it's giving that mu k over here. What will happen if this system is moving? Can you tell me? So if this happen, actually try to understand, this is a very important question actually. It's a tricky little bus but interesting actually. So if you do not understand, please don't hesitate me to stop. This is very standard problem in your level. So what happened when you're going to drag this block M2, so if you say this M2 move towards that positive x direction, what M1 will do? Will the M1 will be stationary or it will move? Come on guys, speak up. Hello, can you hear me?
স্যার একটু M1 আর M2 মুভিং এর ব্যাপারটা আবার একটু বলবেন, মানে হচ্ছে এই সিনারিও ব্যাপারটা।
Scenario is simple. Basically, this M1 is connected by this wall, by this string, and this M2 I'm dragging by this 20 Newton force. If I drag, this M2 will move toward that direction, right? What this M1 will do, that's my question. Can you visualize that part?
Yes, sir.
What will happen? What the M1 is going to do? If M2 moves towards the positive x direction, then what M1 is going to do? Will it be stationary or it will move?
Sir, move.
It will move in which direction?
Negative x, negative y.
Both direction? Why direction it will move?
Sir, নিচে নামবে না?
Oh, fine. I got your point. So that's mean after disconnecting from the surface M2, right?
জি sir.
Yeah, that's you're right. Absolutely, yeah. So, but all right. So that's the part. But we'll only focus when it will be on the surface. So that's mean up to that part we'll consider that this system. I know when you will be disconnected from that one, then the M1 will be definitely moved to the ground one. That's good, fine. But we are not interested. We are interested up to that movement. It's starting from here to here. When it's come over here, what should be the characteristics or the properties over here? Yeah, M1 will be move. There are some relative velocity over here. If I say the velocity of that M1 with respect to the ground, will it be moved?
Yes.
Will it be moved?
নিচের দিকে নামবে না?
No. Up to this part. So let's say one thing. Actually, let's say you are traveling with your car and you are inside sitting in your car. If the car is moving with some velocity, let's say 5 meter per second initially, then you are moving 5 meter per second from respect with the ground or the car. It's called the relative
The
velocity.
car.
Is the car? According to the car, what should be your velocity?
Ground.
The ground. No, the ground. The car এর সাথে 0.
Yes.
Ground এর সাথে হচ্ছে 5.
Exactly. So if you say you are moving inside the car, then you are actually not sitting. You are actually running inside the car. All right. That's do the children actually that infant people, tiny people doesn't sit in the car. They actually that make some chaos inside the car. All right. So forget about that part. So it means that relative velocity. If you say that M1 is moving with respect to the, it should be that M2. But M1 actually is stationary with respect to the ground, right? That's part the play
Yes.
actually the relative velocity. We need to understand that part. All right. So over here they ask me actually that two question. One question actually, what is the tension in the string of the block M1, and what is the acceleration of the block M2? These are the two questions I have to find out over here. Fine. So before I find out that one, I need to draw the free body diagram of these two objects. So to find out the free body diagram, I need to know how many forces actually acting on the block M1. Can anyone tell me how many forces will be acting on the block M1? How many forces?
3.
3 forces. Good. What are they?
সে mg, তারপরে হচ্ছে উপরে n আর হচ্ছে ওই যে m2 এর জন্য যে বিপরীত ফোর্সটা কাজ করবে ওটা।
All right. So this is the normal reaction force, right? This is the tension. That's I'm looking for to find out. Let's say this is the T1. This is the 3 force. Is there any other force over here? There will be one more force. There will be also the
m2 এর জন্য একটা রিঅ্যাকশন ফোর্স কাজ করবে না?
exactly. This is actually the frictional force. Then it should be the 4 forces over here. This should be that F1. Because when you're dragging this M2 towards the positive x direction, M1 actually moving towards the negative x direction, and there will be that friction towards that movement of the opposite direction. So that's why this frictional force will be arise over here. That is the 4 force over here. You understand this part?
স্যার এই পার্টটা আবার রিপিট করবেন?
So look at this. If you keep this block one upon another, this is my block. If this one is moved to that direction, this one will move to this direction, right? Then there will be some frictional force at the surface of this one. The frictional force for this block M1 should be that one, which is F1, and Fk1 it should be basically, because it's moving, right? Because this block M1 is moving towards the leftward direction, then the frictional force will be in the opposite direction. So that's why you can say this is Fk1. Am I right? Because I'm saying that M1 is moving with respect to the M2. That's why there will be the frictional force. I'm coming to that part. It's very interesting. So you'll find out. I know this is confusing, right? Kabbo? Is it confusing?
Confusing.
Yeah.
Yep.
Yeah. It will be clear right now if you understand that M2. How many forces for M2 right now? How many forces for M2?
Sir, 4.
4 force. All right. What are they?
Sir, 20 নিউটন, নিচের দিকে mg, উপর দিকে n1 n2 আর frictional force.
You said all the name. That's good. Very good. But if you say that in weight is the downward direction, then how many weight towards the downward direction? Only M2G?
ও না, m1g ও add হবে, m1g add
Yeah,
হবে.
this would be M1G. So that's why we are doing the free body diagram. And this is, you can say, this is actually that N2, right? This is that applied force 20 Newton, that's you say, which is, I'm going to say that simply the T over here. And what about the frictional force? This is the frictional force, which is, I am say, this is F2, right? And there will be one more frictional force over here. This would be that F1. And this F1, this one are exactly the same. Because when you dragging this M2, this M1 will also try to resist that motion. It will apply some frictional force according to Newton's first law, because initially it was stationary. So it will try to keep as much as possible to make the system is stationary. Right? So that's why when it's moving,
স্যার এখানে তো স্ট্যাটিক ফ্রিকশন নাই, তাহলে এখানে M1 কিভাবে ফ্রিকশনে কাজ করছে?
since it's moving, all right. So that will be the free body diagram over here. Is that okay? All of you?
স্যার F1 টা আরেকবার একটু বুঝাবেন?
Which F1? For M1 or M2?
দুইটাই।
Do one thing, Kabbo. Place your hand one upon another and try to move your hand in the two opposite direction. Do that.
Static friction.
It's a kinetic friction, not the static friction.
Kinetic friction.
All right.
বুঝছি।
Do you understand right now?
হুম।
Yes. So that's why this F1 is present over here. And when you consider for M2, since M2 is moving towards the positive x direction, one frictional force will be due to the surface that's below the M2, and one frictional force will be provided by the M1 that's up to the on the surface, top surface of the M2. All right. So that's why this will be the free body diagram. Now fine. Now let's come to the floor block M1. I'm going to write for M1 what I'm supposed to write. I'll write net force along to the y direction is 0. It's not moving towards that vertical direction when it is on the surface, because I'm concerned about when that block is not moving in the vertical direction up to that part actually, because that will satisfy my condition to find out the T and the acceleration of that block. Alright, so if I write down, then I am supposed to write it should be N1 minus M1G equal to the 0. Look at this, if you look at that block M1, there are two forces only acting on the vertical direction. One is this N1, another is the M1G. So that's why I write in this part. It should be N1 should be simply M1G, that's going to be that 9.8 because your M1 actually that 1 kg. Fine, I find out this one. Now for along to the x direction, net force along to the x direction actually there's 0 because that block is not moving according to my ground surface because I'm taking that my reference frame, right? So that's why it is not moving also towards that. That's why I can say that the net force is 0. Why it is so? Because I'll write down in that case, if you look at this free body diagram, then I can say it should be F1 minus T1, sorry, would be equal to the 0. Only these two forces actually acting on that M1 along to the x direction. F1 is towards the positive x direction and T is towards the negative x direction. So that's why I write down because I choose that rightward actually the positive. So that's why I write down F1 minus T1 actually the 0. Then I can write down this T1 should be simply F1 and I can find out that F1 would be simply mu k into N1, right? Then they give me the x actually the mu k, so I'll write down the T1 would be simply mu k actually that 0.4 and N1 actually the 9.8 is going to be the simply 3 point, T1 is simply 3.92. So this is the tension in the string that is asked in question 1. So that's why this is the answer of question 1. Fine. Now to find out the acceleration, I will consider the block B. You can write down for M2 what I'm going to write. I'll write the same thing, net force along to the y direction must be equal to the 0. Then it should be N2 minus M1G minus M2G equal to the 0. If you look at that free body diagram along to the y direction, this M1G and M2G and N2 would be equal to the 0, then I can find out that N2 over here. So N2 should be simply, if I write M1 plus M2 into G equal to the 0, which will give me, if I plug in this, what is the mass of the M2? M2 is 2 kg, so it should be 3 into 9.8. I'm sorry, it's not the 0. Write down the 0. So that implies 3 into 9.8, which should be 29.4 Newton. That's the normal reaction force. Alright, so now net force along to the x direction. Since this is moving, it should be that MA, the block M1 is moving towards the positive x direction because I apply the 20 Newton force toward that direction. Then I will write down it's a T1 minus F1, not the T1, sorry, it's a T minus F1 minus F2 equal to that MA, right? If you look at that free body diagram, you can find out this part, right? If you look at that free body diagram, look at this. For M2, there are 3 forces, 20 Newton is towards the positive x direction, F1 and F2 towards the negative x direction. Alright? Then I can find out that acceleration from there. So acceleration should be simply T minus F1 minus F2 divided by M, which is simply, I know that T, which is 20 Newton, F1 I find out which is 3.92, and F2 I can find out which should be mu k into N2, mu k actually that 0.4, and N2 I find out 29.4 divided by mass, which is M2. This mass should be that M2, I'm sorry. This M2 actually that 2 kg. Then I can find out this should be simply, it should be simply 2.16 meter per second square. And if you write down in terms of vector, it should be that I hat. That's with the answer. Alright, is there any question over here?
স্যার ক্লাস কি রেকর্ড করা হচ্ছে?
Yes, it's recording.
আচ্ছা।
Let's extend this idea. let's say this is a pulley actually. I'm adding the pulley over here. This pulley is fixed. This is a frictionless and massless pulley I'm using over here. I connected this pulley over here with a block, two block actually. Right, so let's draw the block like this. Alright, this is pretty much like the same case. So right now, instead of that was connected to the wall, I use a pulley over here. Let's say this is my block M1, this is the block M2. Same thing, the mass of this block M1 actually 1 kg, the mass of this block M2 2 kg. Right now the coefficient of kinetic friction is different. That's mean the different material right now. It says the 0.3 right now, and I'm dragging this on by right now applying the tension T, and this T is again 20 Newton. So now I have to find out the acceleration of the block M2 again. I have to find out that acceleration of the block M2. All right. Fine. So let's draw the free body diagram again over here. I'm trying to draw is by a separate way so that it would be easier for you. Let's draw that block M1 first. This is my block M1. Then if I draw the free body diagram for this block M1, I'll find out 4 forces again over here. One force actually your M1G, since this is M1. This is my normal reaction force. Let's say this is that N1, and this is the tension over here. This is the tension over here, and this will be the frictional force for this one. This is the frictional force actually, that F1. Right? Am I right? Because do one thing actually, you can consider that top surface of M2 as a stationary surface for M1. You can consider also that way, because when you're dragging this M1 towards the rightward, so or towards the positive x direction, then this M1 will move towards that negative x direction, and M2 will move towards the positive x direction. Right now it is not stationary, it is moving actually. All right. So fine, to find out that one, what I'm going to do, so this is my free body diagram from M1. Now for M2, if I draw that M2, you can use the different color. Let's say this is my M2 right now. This would be M2G. This would be one more M1G. This would be my normal reaction force into, this is my tension, this is my top level frictional force, which is actually that F1 provided by the M1. This is my down what frictional force which is provided by the surface M2, and there will be one more force which is provided by the tension, which is actually the T1 over here. Right? So this is actually the free body diagram for these two objects. Do you understand this part? Right, so my time is running out. Fine. Fine, so now let's write on, because I'm only concerned about my acceleration, so that's why I'll do for two equation at a time. So what I'm going to do, I'll write for M1, because that both the block actually not moving for vertical direction, so that's why I know that the N1 should be downward force upward. So what I can write for M1, it should be T1 minus F1A should be M1A, and for M2, let's say this is equation number 1, and for M2, I'm supposed to write, so it should be T minus T1 minus F1 minus F2, that must be M2 into A. I'm writing the Newton's second law on both case along to the x direction. These two equations I'll write simply net force along to the x direction, actually that MA, using that one. You can write them the separately. I'm doing at a time actually too, since my time is running out. So I'm going to add them together.
M1 এর acceleration টা তো নেগেটিভ হওয়ার কথা না?
Yeah, I
এটা
take
তো
the magnitude. So I take the magnitude. All right. So then you can do that actually. What I did actually, then it should be minus, it will be plus, it will be minus. If you say the A is negative. Do you understand? Is that okay right now?
Yes, sir.
So I I jump one line actually over here. So then if I multiply, then I will find out this one will be T1 minus F1A. Thank you very much. I do that at a time actually. It should be M1A. This will be my equation number 1. Yeah, you can do that. The same is the same thing actually. Fine. So now I am going to add them together actually over here. This is that equation 1 and 2. If I add 1 plus 2, what it will give me, look at this, I'm writing this equation again over here, or you can subtract T1 minus F1A, it should be M1A, and it should be T minus T1 minus F1 minus F2, it should be M2A. If I add them together, this T1 will be cancelled out, right? Then I will find out this thing would be T minus 2 F1 minus F2, it should be M1 plus M2 into A, right? Then it should be simply T minus 2 F1 minus F2 divided by M1 plus M2. All right. So I'm going to do one more line actually over here, because you can find out those part, I know. One. So it should be T minus 2F1 would be 2 into mu K into M1 N1, which is M1 into G, right? For F1, this N1 should be M1 into G actually. You can find out along to the y direction. You can find out along to the vertical direction. And this F2, which is actually that mu K into N2, and N2 should be M1 plus M2 into G, right? Then I will write down this one should be simply M1 plus M2 into G divided by M1 plus M2. You know the everything over here. You know the mu K, you know that M1, M2, and you know also the G, and you also know the T. If you plug in all those things, then you will find out this thing would be 1.76 meter per second square. So that should be that acceleration. If you want to express in terms of vector, that's going to be that actually your acceleration of this block. Two block that has the same acceleration, right? Both block has the same acceleration. Whether they ask me to find out the acceleration for the block M2 or M1, it will be the same acceleration over here. Alright, so your time is up actually. I cannot start that second part actually. I'll do in the next class actually. I'll do one more problem from here, or I will start the Newton's law, actually the new circular motion actually in the next class. Alright. Okay, well, do one thing guys, give your attendance into the chat box.